Hello and welcome to the live stream event by Yalantis, dedicated to the IoT landscape from modular data processing to cutting-edge computing. At Yalantis, we help businesses to bridge tech leadership and tech talent gaps with modern IoT technology and software development practices so you can scale, innovate, and monetize your products and solutions. I'm Victor Asachi, and I will be moderating today's event. This is kind of a pre-party before the IoT Tech Expo Europe and the Things Conference that will both happen in the next few weeks in Amsterdam. And our Yalantis team, dedicated to the IoT industry, in particular Denis Hukov, the head of the IoT unit at Yalantis, will participate in both events together with our customers. And if you're going to be there as well, let us know in the chat of the stream. We'll be happy to meet you and network together. All right, but let's get to the point. In an era where data is the new oil, understanding the rapidly evolving landscape of the Internet of Things is no longer an option. It's just a business imperative. We meet today for an inclusive dialogue dedicated to the IoT landscape, from modular data processing to cutting edge computing, learning how modular architectures are giving way to the transformative computing paradigms. See how not just to adapt, but to strategically position your organization at the vanguard of the technological revolution. We have about 1.5 hours ahead, and every guest speaker will have 20 to 25 minutes for the Q&A session. So please type your questions in the chat so that we could answer them. And the fantastic speakers of today are Alexei Ivanchenko from Amazon, Denis Doronin, and Denis Hukov, both from Yalantis, and I really can't wait to start. And the opening speaker will be Denis Doronin, our Chief Technical Officer here at Yalantis. Denis will delve into the most common business challenges and discuss how they can be addressed through specific architectural decisions. And he will also present the architecture of the IoT accelerator and explain its technological benefits, which allow businesses to speed up their time to market and reduce development costs. Denis, welcome to the IoT Landscape Live event. The stage is yours.
Hi everyone, thank you Victor. Hi everyone again and welcome to our today's webinar. I'm honored to start our IoT meetup today, and actually through today's sessions, as Victor mentioned it, we will explore cutting edge trends and share valuable insights regarding IoT. So thank you everyone for joining us today, and let's make this webinar informative and inspiring for all of us. So, as we mentioned, our first topic for today is modular IoT data processing. Let me share my screen with slides, and we will begin. Okay, so why IoT platform? We actually built multiple IoT platforms for our clients, and during different projects, we observed several patterns that may be used across a wide range of IoT domains. We asked ourselves a simple question: how can we save up to 45% on architectural design and actually basic implementation? Is it possible to do? Is it possible to build some sort of platform or accelerator that will be flexible enough to support business scalability? Let's take a look. But before we jump into the topic, I would like to spend just a couple of minutes telling about who we are. So Yalantis is a full-scale company founded in 2008 that provides end-to-end consulting and delivery services. We are focused on domain and technology consulting, and as part of our delivery services, we can become development partner and staffing partner. Our key differentiator is scalability. So actually we have multiple cases when we build a team from 0 up to 50 people within the first months of our engagement, or even up to 150 people within a couple of months. It's also important to mention that we are ISO certified company. So As I mentioned, we can take two primary roles. We can become consultant, so we provide set of advisory services like strategy design, business valuation service, and technical solution design. And as provider, we can focus on delivering solutions on different stages: prototyping, assessment, migration, cloud modernization, and of course, end-to-end implementation services. We are not limited to particular technology or language. We are a diverse company that can suggest you actually appropriate technical stack of your choice. Continuing topic of our capabilities, Yalantis has more than 500 in-house developers. We have delivery centers in 3 different countries: Poland, Ukraine, Cyprus, and we have sales office in Estonia. So, without further ado, let's return back to our main topic. First, I would like to start with a little bit of background in IoT. So typically, when we are speaking about technical or technological subdomains in IoT, we can define some sort of 6 main areas. The first one is connectivity. When we are speaking about different protocols and communication from edge devices to some platforms or between edge devices. Speaking about device management, the main task is to provision, monitor, or update your devices, right? So that's the main goal of this technical domain. As for embedded development, of course, here we are focusing on developing firmware or developing custom applications for your edge devices. Basically, the last 3 services are related to interconnection of everything you have in terms of physical devices with your end users. So data management, really essential component of any IoT system that can actually data and build valuable insights out of what you have on your edge devices. Application development service or direction, where you're actually focusing on developing end-to-end flows for your users. And middleware, that is essentially data routing, or sometimes middleware is used for data transformation and aggregation. So how can we help with our modular platform? So actually our platform introduces new architectural style for IoT systems based on our previous experience and based on what we observed so far. So we will tackle basically 4 out of 6 main directions. We will speak today about connectivity, data management, application development, and middleware. So that's basically essential parts that are handled by our platform. Let's take a closer look. So first we will dive into technical details starting from our business architecture. Actually, our platform operates on 5 different tiers that are designed in a way that they can be interchangeable and isolated from each other. So everything really starts from devices tier, where you have actually your physical devices, edge devices that are streaming data, sending you some statuses about how it operates, make some periodical events. So that's essentially a place where you are generating your data. Then actually our platform starts with data collection tier. So essentially, our platform acting as an entry point for your data from devices. We collect the data and we then push the data to the next tier called messaging, where we are actually handling part related to middleware. So here we are routing data, transforming data, aggregating data, and then we are sending it to processing tier, where you can build different metrics, build real-time metrics, or run historical queries over your data. Of course, we will need some sort of data storage, and the main quality of that storage should be high availability and security. And essentially, to build, for example, client application, so connect it to your BI tool, we will need some sort of backend logic here, where we will actually implement applications that will query the data or actually build some rules over the data. Of course, if we are speaking about client tier, so there we can build different web applications, mobile applications. So client tier is not limited to any particular technology or direction. Here we want just to show that we can interconnect our platform to basically any representation you want, including existing BI tools like Tableau, Google, Data Studio, Power BI, or any other. Okay, moving to business benefits. As I've said, such modular approach will help to save up to 45% on design and MVP implementation, because basically you will get infrastructure within days. So we have everything automated. That means that we can provision infrastructure really fast, and basically we reserve just a couple of days in order to fine-tune our automation scripts and actually make it according to your specific requirements. That's all, of course, reduces MVP go-to-market time, because you can start implementing your business flows, and you can start building your business logic from the very beginning. So you will not have any intermediate results. You can actually start building applications from the very beginning. Of course, that decreases management costs, and we don't use any specific technology in our architecture. So we use well-known solutions. They are all well-known on the market. So I will show you on the next slides how we achieve that. Speaking about cost benefits, in time we can save up to 8 weeks of development, because as I said, we have automated our provisioning scripts, we developed integrations, and actually we have application skeletons that can work with our data processing and data storage tiers. Speaking about running cost, so we measure it that single environment may cost you from $500 for MVPs. For medium-sized businesses, let's say you have like 10,000 devices that should be connected to your platform, and you would like to run different queries and build different metrics. That may take around $2,000 for production environment, and for big enterprises, we can offer solutions that will cost around $4,500, and that's just for operations in specific cloud. So basically, we can optimize cost based on your concrete requirements, and of course, it depends on how many data you generate and how many users you have within your platform. So that's just basically a starting point for discussion. So we are not limited to like particular number, but just to give you a sense of how much will it cost, we provided such estimates. As a part of our technical excellence, we actually thought about 6 main qualities for our platform. First of all, we think about high availability for data processing and for data storage tiers. Because if you cannot access your data, you cannot build metrics, you cannot access real-time dashboards, you cannot run queries. Of course, that affects any type of business. Then one of our key qualities was scalability and performance. So basically, we were thinking, how can we apply our platform to different business size? How can we support from 100 queries per second up to millions queries per second, right? So that's an important stuff. How can we scale our architecture to support such requirement? Then actually what essentially drive our architecture is modularity and modifiability. So basically, how can we modify our tiers? How can we change different models within those tiers? How can we redeploy without any effect to business? So we thought about different scenarios and different um, cases when we need modularity and modifiability. Of course, we understand that businesses may have existing technology stack and existing BI tools, so we need to think about interoperability. So how can we connect our platform to different tools? How can we build different clients? How can we achieve that? It's an interesting question, right? About privacy and security, basically, how can we protect the data? Because securing edge devices, securing data transmitting to the platform and storing into the platform is a key requirement for any kind of platform, right? And last but not least is operational efficiency. So basically, how can we optimize running cost? How can we build a platform that may be customized on flight without redeploy? So particularly data processing tier and data collection tier. Okay, so let's take a closer look. Um, Actually, it was to mention that our architecture was designed as a cloud agnostic approach from the very beginning. We don't limit ourselves with constraints and limitations of existing services. So our thought process was that we first define components and their responsibilities, and only after that we build and select services that actually will perform that role. So speaking about data collection tier, for example, we will need some sort of balancers in order to capture any event from our edge devices. We need data collector model, data collector thing that will actually take all of the data. In messaging tier, we would like to have some sort of message bus that basically routes the data from our edge devices to processing tier. And speaking about two tiers, processing tier and data tier, we are following what is called Lambda architecture in big data space. So basically, that's a type of architecture where you have essentially two main streams. The first stream is for real-time analytics, so it's called like speed layer. And as for batch processing or historical queries, we will have another layer that actually called batch layer or batch processing. And then in data tier, actually, we have different types of storages. So essentially, processing tier and data tier combines data warehouse, data processing, caching, and raw data. Uh, Last but not least, backend tier. Here we may actually propose different types of architectures, different types of structures. So here we may have service-oriented approach, or may have some sort of microservices that will suit for some low-level specific operations with the data, and so on. Okay, so let's take a look into concrete architecture. So as I said, first we built cloud agnostic architecture, but then we transformed it into specific architectures for different clouds. So on the screen right now you see AWS version of our architecture, and this architecture is suitable for what we call rapid starts. So basically, this type of architecture helps you to start project as fast as possible. At the core of our whole architecture for processing tier and data tier, we selected technology called Apache Druid. So it's a high performance real-time analytics database. It suits well for IoT data. It has all the capabilities for real-time analytics, for sub-second queries, and provides many interesting features that may be suitable for intelligent data processing. As part of our architecture, also here we used multiple managed services. So for example, for data collection tier, we suggest to start with AWS IoT Core as a basically service that can operate with different protocols and different types of edge devices. And as for messaging tier, here we selected Apache Kafka, but managed version of it from AWS called Amazon MSK. So that means that if your business has, for example, existing data collection tier, so for example, you're already collecting the data out of your edge devices, we can just keep data collection tier from our platform, and all we need to do is integrate your existing components with our messaging tier. If you don't have data collection tier, we can provide an option to set up, for example, as we said, AWS IoT Core, or for example, build any custom data collection models if needed. Speaking about backend tier, right now our skeletons are written in Python. So we uh, wrote a special application that connects to Apache Druid or actually to processing tier and takes all required data and metrics. But we are not limited to that language. Again, if you have any preferences on backend languages, we can rewrite the tier using your language. And actually, as I said, here on the screen, we are showing an option how we can connect it with Tableau and how we can connect it to different web clients or mobile clients. So it's also feasible to do with this platform. Okay, sounds too suspicious, right? Lots of benefits without any proofs. For that reason, we actually built a prototype that uses our platform to demonstrate our capabilities. We selected energy management domain, and with help of our platform, we built end-to-end scenario for electricity consumption management across set of buildings with hundreds of devices. Actually, our solution shows multiple dashboards for different roles like operational manager or building owner to demonstrate real-time capabilities and reporting capabilities. Specifically, for example, energy consumption per building, device energy consumption for some specific period, total consumption, and real-time device consumption. So, hope that was interesting insight. Uh, of our platform. And I hope now you can see how we can accelerate essentially any type of project using our accelerator. And of course, you can use this architecture as a reference for your own solutions, because here we, as I said, introduced new architectural style, and we did like a heavy job in terms of consulting and selecting appropriate services and building different tiers for future solutions. So now I am open to your question. Thank you, everyone.
That is great. Thank you, Dennis. It was really insightful. Lots of details on the solution and the modular architecture in general. I have some questions from the chat for you, if you don't mind. And the first one sounds like this. You showed an example in the energy management sector. Does it mean your solution works only for this domain? And can it be used in other directions like manufacturing, smart homes technologies, and industrial IoT?
Thank you. It's a great question. Actually, our cloud agnostic approach uh, transforms not only to technology choice but also to different business domains choice. So as I said in the very beginning, we are focusing on patterns. So that means that we would like to generalize our approach and scale it to different business domains. And yes, we are not limiting only to energy management domain. We can use our accelerator for manufacturing, for healthcare, for smart homes, for any type of solutions where you have essentially hardware devices. And it doesn't matter whether it's a particular business domain. So our goal is to introduce end-to-end platform that allows you to build features rapidly. So you can bootstrap platform, and then you can start building UIs, you can start building clients, you can connect it to your BI tools and work with data intelligently. Hope
That's
that
great.
answers
Thank
your
you.
question.
It really does. Yes, thank you. It was exhaustive, I guess. Another question for you. Is it possible to integrate the platform with the existing company technology landscape? And what would be the approach?
Yes, it is possible. Definitely, it's possible because that was one of our quality for interoperability and modularity. So, as I've said, on our tiers in backend tier, we can use different languages. So, essentially, core of our platform is processing tier and data tier. That means that after we routed the data to processing tier, after we did all of the processing, aggregation, and transformation, we can build any backend application that will consume the data. So again, if you have different technology stack, we can adopt our platform to what you have inside your existing business.
That's great. And the very last question that we have for you is: have you implemented projects using out of the box IoT solutions like Azure IoT Central?
Yes, actually, we have a different version of this architecture for Azure, and there we have multiple options what kind of services we may use. But yeah, essentially, we can think about combining those services as well.
Thank you so much. I have no more questions from the chat. Thank you again for your report and for your presentation. It was really cool and insightful, especially the idea of being flexible and modular in terms of architecture and repeat development, especially the fact that it really reduces the time to market and the development costs, as well as the proof, which was, I guess, the essential idea of why it is so necessary to adopt such technology. But we will have to go on. Let's proceed to our next speaker. Thanks again, Dennis. And now we talk about the next topic, and there will be some questions covered. What are the advantages of the IoT edge computing technology? What it offers to the market, and what stands behind its growing popularity among businesses? Why edge computing may be a groundbreaking force in reducing latency, overcoming bandwidth requirements, and exploring the security implications of edge of computing. Denis Hukov, the head of the IoT unit at Yalantis, our second speaker, knows the answers to all of those questions. So, Denis, please join us. The stage is yours.
Yeah, hello guys. One more Dennis is here. So let me share my screen and let's Mortal or Edge Combat begin. Here we are. I hope you can see my screen now. And let's go. So Victor already told you about my topic, so I'll jump directly into my agenda. So the agenda for today is edge computing as a technology and edge to cloud synergy. Actually, business impact of edge computing to your company or to your business, and future trends of edge computing, and of course, its stack or vendor selection for edge computing implementation. Let's go further. And for this slide, it's a small warm up for you, actually. So what you can see on this slide, it's two planes, two flight jets, and they are kind of the same, but they are different. And the difference between them, I will give you a few seconds. 1, 2, 3, 4. So the main difference between them is the pilot view. As you can see here, And here, so that's the previous version of the jet, and that's the newest version, like newest for the Second World War, actually. But here it's the view. And view gives what? View gives more information or more data. And what does it mean, more data about battlefield? It's about surveillance. So it allows to make vital decisions faster. So main point here is the speed of decisions has meaning. And let's start from terminology, because we need to clarify some terms, because there is a lot of confusion about edge computing. You will understand why I said about speed of decisions later, because it's definitely the core aspect of edge computing overall. And let's clarify some terms. There are a lot of discussions, and people seem to be talking about different things, speaking about edge and about edge computing. And it's actually essential to use clear language. So let's start from this point. And what is the edge? Edge actually is where the client endpoint device is located. And what's really far in the real world, the far is the cloud. The far is the data centers, yes? And overall, edge computing is a term that refers to smart computing resources situated near where data is used or created. So, as one of well-known guys said, Leonard Lee, he says edge extends from the default location to anywhere and anything, but not the central cloud. Let's go further. And on this slide, I just want to show you a little bit trend of popularity of edge computing. Yes, and by 2028, majority of enterprises will be using edge computing according to the Linux Foundation. And in addition, Gartner predicts that by 2025, more than 70% of organizations, frankly speaking, I don't really believe in this statement. However, they predict like more than 70% of enterprise generated data will be processed outside a traditional centralized data centers or clouds. So we are speaking about edge and we are speaking about the cloud. Let's just try to compare both of them. What advantages and disadvantages each of these solutions have. And as the volume and velocity of data increases, so to that the inefficiency of streaming all of the information to a cloud or data center for processing. And edge data is often too big to move. Actually, that's really big. Let's assume just, I don't know, recordings of high quality video, and you should just send this information every second, and for 1 second, and it might be a few gigabytes of data, and that's a huge problem for cloud. And processing edge data at the edge allows us to generate value that simply was not possible even just a few years ago. Also, we are facing, you probably also like aware of that, to be faced with the growing complexities of the public cloud. And that's a lot of innovation that's like AWS or Azure or Google gave to us, and a lot of new features, but it's sometimes too complicated and cumbersome, yes. And what sets edge computing apart from cloud computing is that the server is positioned outside of traditional hyperscale public cloud environments to corporate data centers. And the edge server is strategically located nearer to the primary site where this data created. So it gives us speed, as I said, speed of decisions, and reduce the latency. You probably can compare all of that. I don't want to stop in here for a while. Let's just move further. What's actually driving the shift back to edge computing as a trend? Why I said shift back? Because actually manufacturers have been deploying gateways and servers on their factories, on their facilities, on premises for a while. And so what's now driving to move back to the edge computing trend? And I prepare kind of reversed root cause analysis. Yes, it's about about benefits of edge computing. And there are 4 core benefits from my point of view. It's operational efficiency, it's about decision making, it's about security, and it's about costs. So from my point of view, businesses can't tolerate cloud-related delays anymore. Some of businesses, not all of them, obviously. And nowadays, companies heavily rely on getting quick, real-time information. Any processes needing fast data access must have computing right where the data is created and used. This becomes even more crucial when we are using AI or ML, machine learning. So because quick analysis and decision are crucial. The cloud has limitations when it comes to providing instant feedback. The edge offers companies more opportunity to keep the data within their own walls. For instance, in a lot of countries, like hospitals, they cannot upload the data to the cloud. So they have to have these edge servers on premises. And that's one of the points. As concerns of software supply chain lacks and security threats continue to grow, the edge removes the need to constantly move large amounts of data. It's also about the previous example. And edge computing allows a remote server or data center to act independently, regardless of outages or connectivity issues. Speaking about costs, it's also became a normal thing for now to pay a lot, like a few $1,000s per month with cloud services. Yes. So if a company has its own computing power, it can be more cost effective than handling it in the cloud. Of course, we should consider to take in mind like the price of maintenance of the system and operational expenses for specialists. However, it's still worth it for a lot of companies. Also, edge computing uses less internet capacity and network resources because devices don't have to constantly connect online for data transfer. This cuts down on the expenses associated with network costs, network usage. So, edge computing eliminates the need to move data since it's processed right where it's generated, reducing the amount of bandwidth need to handle data. And actually, if managed correctly, with processing at the source, edge data can drive vast new businesses opportunities and manage tasks that have until now been manually costly and even often unreliable. And where you can use it, yes, which spheres, which companies should do this edge computing. So as we discussed before, edge computing allows companies to extend their opportunities for data collection and analysis, service provision, security, decision making, and improving overall business productivity. However, it's important to envision the potential benefits for your business when it gains a clear view right to the outer edges of its operations. So to do that, each business should answer the question, what improvements to your products or services could become possible when you will integrate edge computing? So sometimes you just don't need edge computing, that's fine. And there are a few examples like manufacturing. In case of any unexpected outage or issue, processing on the edge can save you much time and money by either predicting system malfunctions or notifying you in case any critical issue has occurred, or in case of bad quality of your product. It's better to define this bad quality on the line, not sending this bad quality product to your end users. That's obviously. Healthcare, it's also remote patient monitoring, diagnostic, robotic surgery, so it shouldn't be any latency in here. Immediate emergency response are life-saving examples of edge computing applications in the healthcare industry. Agriculture as well, so it's monitoring crop growth, soil characteristics, when you need to gain data and make decision like, really fast. In retail, it's also useful. You can analyze shopper traffic flow within stores to determine where high margin products are based to be placed. It's also about security. You can check like if someone want to stolen something, yes, from your store, for instance. Smart cities, it's actually, that's the great example. It's a large distributed network of smart devices across large cities allows edge computing to reveal like to create magic. With edge computing, city authorities can maintain control of all over the city and immediately react in case of emergencies, or even take proactive measures in response to potentially hazard situations. It's also about managing traffic, I don't know, parking lots, public security, a lot of different things. Let's move next. So here you can see a few layers or types of edge computing. That's a little bit complicated. Let me to explain to you. You can see here, the bottom, it's micro edge, then thin edge, then thick edge, then cloud. And you can see it's latency decreasing, but distance increasing. So what is that? Micro edge describes the intelligent sensors devices that generates data. Micro edge devices are typically equipped with low-end processors due to constraints related to cost and power consumption. Thin edge. Thin edge describes the intelligent controllers, networking equipment, and computers that aggregate data from the sensors, devices generating data. Thin edge compute resources are typically equipped with middle tier processors, and sometimes they also include AI components. So there are three types of compute resources related to thin edge, and that's computers, network equipment, and controllers. Moving forward, thick edge. The thick edge describes compute resources typically located within a data center. So here is like distance between 100 meters to edge device to even 40 kilometers approximately. And here it's like two main sources. It's cell tower data centers or on-prem data centers. And what is the three main types of architecture? The first one, it's obvious, it's pure edge. Yeah, so that's 100% edge architecture. These architectures do not include any off-premises resources. So all of them resources are on-premise. 100% edge architectures, like pure edge, are often used by organizations that do not send data to the cloud for security. Due to some privacy reasons. So it might be defense suppliers, pharmaceutical companies, or large organizations that have already invested a lot of money in on-premise computing infrastructure. Next one, that's what we discussed, thin edge, but thin edge plus cloud architecture. This architecture allows include cloud compute resources connected to one or more smaller edge compute resources. So thin edge architectures are often used to collect data from remote assets that are not part of existing plant network. And thick edge plus cloud architecture, these architectures always include on-prem data center plus compute resources, plus cloud compute resources. And optionally, it includes other edge compute resources. So here you can see like three different types of architecture, how we can use this edge. And from my point of view, there are going to be next step when we will move forward mostly to edge cloud. And some of the companies that have a lot of money, they can make pure edge, or the companies that need to do that. All of other companies probably will have kind of hybrid cloud edge. So here you can see like the integration advantages of cloud and edge. Providers of cloud, they understand all of this stuff, definitely. And that's example of AWS. So AWS already created a few products. I just mentioned, for instance, a few of them. That's AWS Outposts, AWS IoT Greengrass, and AWS Wavelengths. So all of them used by different reasons. However, that's all related to hybrid cloud edge solutions. And why do we actually need this hybrid cloud edge? Why don't we use just cloud first? Or why don't we use just pure edge? So the thing is, that's great, kind of sort some information, but store this information for a long period of time on the cloud. So intelligent edge computing, on this slide you can see the schema. So the first is like sensors from one unit. They can generate, as you can see on the slide, 30 gigabytes per month. Sometimes it's even more. If it's related to cameras, machine vision, it's going to be even more. And then edge computing device, intelligent edge computing device, they analyze this data and send only crucial data, important data. It's like 150 megabytes per unit to the cloud. So the edge layer serves as a filter for your business critical data. Edge nodes can also process certain time sensitive data, but send to the cloud only the result of this processing. Like I already told you an example. For instance, IoT sensors installed on a compressed air system in an industrial facility, and they can constantly assess the system state. Imaging an IoT sensor spots an issue, then transfer information about this issue to the edge node installed in the same facility for immediate processing. Then the facility worker gets notified, like immediately, of this issue via the certain web portal to take immediate action. That's edge computing. But after the action is taken and the system work has resumed, the edge node can send to the cloud a brief report, not all of this information, just a brief report on when the issue happened and how quickly it was resolved. So that data analytics later conducts through analytics on how often the system falls during a certain period of time and how it affects business costs. So we can start machine learning in here, yes, and continuously improve our processes. Is everything so cool with edge computing? Of course it's not. There are a lot of challenges like data privacy and security. It's like the funny thing that it's duplicating strong sides of edge computing. The strong sides, it's also weaknesses, yes? So it's data privacy and security, training and adaptation of your staff or processes in the company. It's limited computational resources, but it's right now getting used to be better. Edge device monitoring, maintaining uptime and reliability in remote edge locations, and scalability, because scaling edge infrastructure to meet growing data and user demands, it's complicated. And speaking about your business, when edge computing should be chosen, we've already discussed the common benefits of edge. Yes, there are a lot of them. And here it's just the question, if you ask yourself about them, it's going to be easier to make a decision. Should you choose edge computing, or should you go with only with cloud, or should it be hybrid between edge and cloud? So when you see the necessity for real-time data analytics to ensure a better level of visibility within your organization, please choose edge computing. When the low latency, crucial for you, for your decision making, choose edge computing. When you want to ensure the highest level of business continuity and eliminate outages of your business critical application and devices, use edge computing. When your organization generates large volumes of data and the distributed nature of data storage and processing that edge computing offers can be beneficial. You can also choose edge computing, and then it's critical for you to ensure the security of your business data locally and reduce the chance of fraudsters intervene in your edge IoT devices. That's kind of it for this part, and let's move to the trends. I don't have a lot of time, but let's go quickly through all of them. So the trend not only for edge computing but for all spheres of life for now is security, and security importance and regulatory compliance. That's really important thing. And the trend is enhanced focus on edge security and data processing. It secures closer to data sources. Growing importance of regulatory compliances on the edge, ensuring data handling adheres to regional and industry-specific regulation or laws. So that's really important part, and that's trend for the next few years. Next point is synergy of 5G and edge computing. So 5G gives us massive bandwidth, And 5G brings to the market great features that make ultra-reliable, low-latency mobile wireless communication a thing. The advent of 5G will open up opportunities for a wider array of edge application that can leverage its real-time and dependable attributes so soon to be available in a private to operator network in your vicinity. Keep an eye out for further developments. And 5G network have the capacity to accommodate a significant number of devices, enabling the emergence of new categories of intelligent connected devices. And of course, it's AI, edge AI. Integration of AI and machine learning directly at the edge devices for real-time data processing and decision making. That's going to be really beneficial. The data at the edge, whether structured or unstructured, is valuable. Many organizations have gaps in their data, and edge AI can fill these gaps by making data machine readable. So this is important for companies looking to improve their operations and gain better insights from edge data. The embedded community is getting ready for hardware and devices supporting AI and ML execution at the edge. This means massive hardware design changes and complexity, and an increased software stack complexity as well. Therefore, we will briefly speak about software stack. So for companies, C-level of companies, generative AI holds a lot of excitement, but it also brings some security issues. And edge AI can assist enterprises and consumer software companies in using this technology securely and privately, avoiding potential risks associated with public generative AI tools. Next point, I don't have enough time in here, like machine vision. It's going to be, from my point of view, key technology, especially in manufacturers. Yes, it's about also supply chain. It's about security. It's about a lot of stuff, even healthcare. Autonomous driving. So without edge, without AI, that's actually something impossible and unreal. So edge computing is used to process vast amount of data from various sensors as cameras, lidars, and radars to perceive and understand the surrounding environment and to make fast decisions quickly. And just a few slides left. So I want to briefly go through this topic as this might be crucial for the business. Scalability, security, technical gaps. There are and more other possible risks between like partnership challenges came in my mind. As technologies and solutions became more complex, companies are increasingly partnering with others to integrate their experience and provide complementary services to customers. So let's start from stack. Yeah, what is the best technology choice for edge computing? One of the most suitable technologies is subjective, but it's Rust. Relatively new programming language that is taking over the market. Its most discussed advantages are speed and security. So in terms of edge computing, Rust provides a number of benefits such as easier code review, security audits, and more in comparison to Golang, C, or C++. Faster task execution compared to Node.js and Java, absent of runtime, making code written in Rust work faster as a Python, and the small memory footprint, which helps Rust work with not so powerful hardware, and that's vital for edge computing. So if you are considering edge computing, you should pay attention to Rust 100%. And how to choose your vendor. It's not about only software development. It's about buying some products, yes, ready solutions. So if you want to switch to edge or develop some IoT solutions, you should pay your attention on such things like solid track record of success cases, mature specialists on board, security department and compliances, because that's crucial, that's important, and technical support afterwards. It's not limited by this, as I mentioned before. It's much more like prices, long-term viability, solution accelerators, transparency, management, quality department, many other aspects that you should consider. But from my point of view, that's many of them. And that's actually pretty it from my side. I cannot say like edge computing is at a tipping point. It's time to unleash the potential of the edge. Yes, I will never say that cloud is dead, but I can say long live the era of the edge. Thank you.
That sounded powerful. Thank you so much, Dennis. Well, I was surprised about the statistics of adoption forecasted by the report you've provided. And I actually have a question dedicated to this topic. You mentioned the statistics, and we're hoping to get like 70% level of adoption among businesses. But what about the clients? The question sounds like this. Is it a common tendency among your clients to adopt edge computing?
Yeah, thanks for this question. That is not yet, I would say, but it depends on client. It depends on organization. Because, as I mentioned during my slide deck, not all of the companies really need to have this edge computing. Yes, not all of them. But if you're speaking about manufacturers, yes. If you're speaking about latency and fast decision, 100% yes. But from Yalantis side, it's still mostly hybrid. It's not pure edge. That's edge plus cloud.
I see. I see. So it's like in transition, right?
Yeah.
All right. Thank you so much. And just one more question for you. In what way does the transition to edge computing influence a company's revenue? And what is the typical return on investment in that case?
Yeah, thanks. That's a great question. So, from revenue, I would say it's mostly about decreasing operational cost. However, speaking even about return of investments, about revenue, we should understand total cost of the ownership, yes, of this edge computing device. Because let's assume if you have a lot of places and you created a huge network of edge devices, yes, you need somehow to maintain to support all of these devices, and it's also additional costs. So you should consider all of this stuff, and then carefully count should you take this decision to switch to the edge. But overall, mostly it's still positive ROI. I hope I answered.
Yes, yes. Thank you so much. Thank you so much for sharing your experience and giving such, let's say, an intro into the world of edge computing, which was really insightful. Thank you so much for this. Thank you for your report. Just wanted to give you a quick reminder, all of the audience and listening, those who are listening to us. Denis Hukov is attending the IoT Tech Expo Europe and the Things Conference that will both happen in the next 2 weeks in Amsterdam. And if you're going there too, just let us know on LinkedIn. You actually had an opportunity to join Dan's LinkedIn profile on his presentation. And if you are going there, please let us know here in chat or on LinkedIn, or you can actually email us at hello@yalantis.com. So that we could meet there and just be happy to meet you there, to network together and have an opportunity to chat about the edge computing and the overall IoT industry. Thank you so much, Dennis, again, for providing us with the information. And I guess it's the right time for us to move on to our third speaker. And it's a pleasure to introduce Alexey Ivanchenko, a solution architect from Amazon. Alexey will share firsthand experience on how to use the AWS IoT for storing, analyzing, and visualizing data. He will delve into the AWS IoT capabilities for managing and monitoring IoT devices, as well as what AWS IoT is able to provide in terms of device software. Alexey, welcome on stage. Welcome to the Yalantis IoT Landscape live event. The stage is all yours, please.
Thank you, Victor. Hello, everyone. Thank you, Dennis. Thank you, Dennis, for really great speech and presentations. Was pleasure to hear it. And let me introduce myself. My name is Alexey, Ivanchenko. I'm working for AWS for a little bit more than a year, working from Czech Republic for Ukrainian customers. And today we are going to talk a little bit about the services that we are having in AWS to help you with your IoT workloads. Let me share my screen and we can start. By the way, on the meeting, we also have my colleague Jan Schwab. He is currently in the listen only mode and reading mode in the chat. So if you would like to ask whatever questions you have regarding AWS or IoT, feel free to post them into the chat. He will try to respond as soon as possible. So let's start. Basically, as all of you may notice that IoT market continue to grow at an aggressive pace. What this means for a company or team managing an IoT devices or connected products platform is that they can expect to build and launch more and more connected devices. And at this speed, they need to have ability to effectively manage all the connected devices in their fleet at high scale. And when we are checking the variety of our customers, we can see that our customers like Fender is using IoT for optimizing manufacturing. Philips is using IoT devices for remotely monitoring patient health care and tracking inventory level in their warehouses. Such companies like iDevices or iTron using it for connecting homes, buildings, cities, and Bayer are using it for growing crops. And more use cases all around the like high variety, a big variety of our customers, including transportation, including safety, including the managing of energy consumption and resources, agriculture, whatever. Basically, every field what you can imagine right now. And in essence, you need three different types of services and software when we are talking about the IoT in the cloud and on the edge. It's IoT device software to build devices that operates on the edge and work with the clouds. It's IoT connectivity and control services to connect, manage, and secure your devices at the scale from the cloud. And IoT analytics services that make sense of IoT data, take actions to solve business problems. And it's not like layered architecture, or we should not consider it as the layered architecture. It can be used independently, it can be used in connection, can be used in variety of ways. And we are trying to cover all the these kind of topics, this kind of the requirements with our services, with variety of our services. Across myriad of the customers that we are helping to connect their devices to the cloud, we constantly see set of common challenges connected to the product space. We see top four patterns when we are talking to our customers. First one is extracting value from IoT. For customers new to IoT and haven't connected their product to the cloud, it can be challenging to find the business model that supports the additional development effort and operation costs on IoT solution. However, leveraging the cloud is actually bringing them new ideas and new ways how to get additional revenue streams, um, open new potential products with new innovation and series. Another challenge is managing and scaling large fleet of the devices, which is always a big concern for the customers who are expecting to increase their fleet to like huge, really huge sizes. They can start with tens or hundred of the devices and eventually scale to millions or uh, tens of millions of the devices. Managing a fleet can be really challenging, and AWS is helping with their services. Also, we are seeing the customers that are um, struggling with managing devices itself, with deploying and delivering new software, new functionality to their devices securely in the control cycle with the best practices on it, which are also can be solved by the services that are provided by AWS. And security is always a job zero for the AWS, and using our technologies like Greengrass IoT core, helping our customers to keep devices, data, and customer information secured and protected. So when the customers are coming with the question, how can I connect my data securely and handle the data that are generated at scale? We are coming to our connectivity and control services. And one of our main services in this section is AWS IoT Core. Um, IoT Core is the serverless platform that consists of um, multiple components that are supporting you in your journey in your daily life with your IoT devices. It consists of the identity service providing the authorization and authentication mechanism for your devices using the certificates, using secret password, using different other custom methods for the authorizing your devices. This is device gateway to securely connect your devices to AWS cloud and other devices. It consists of the message broker for processing and routing data to the cloud. Rules agent is one of the uh, hearts of our IoT core capabilities, which can recognize and trigger our big variety of services in AWS based on the events that are coming from your devices, from your edge computing devices, from gateways, finding the patterns and do some additional computation and trigger such devices, such services like Lambda function, Kinesis, like step functions, huge variety of different services in the AWS. Also, device shadow is very interesting capability that allowing you to control and manipulate your devices even when your devices is out of temporary out of the internet connectivity. So it's basically making the shadow of your device which are holding the last state of device which were connected to the network, which were connected to our infrastructure, and holding the state, and then you can manipulate with this state while the device is disconnected. And as soon as device will be connected to the internet, connected to our services, AWS IoT core with the device manager will synchronize all the state, will it have the mechanism for solving the conflicts if there was any kind of the different commands that are coming from different sides, and help you to manipulate your devices even if the connection is not persistent. Also, there is the registry where you can enrich your devices with additional metadata, search it across millions of the devices, or use device locator to find and group your devices based on the location of your devices. As part of the IoT core, there is the IoT core SDK, which allowing you to do the high variety of different adjustment of your devices and connecting them to the cloud to do different procedures. It's abstracting MQTT protocol to have more user friendly and easier way to manage your topic, shadows, job, and so on. It support mobile and device SDK. It has the mobile and device SDK, and mobile SDK support platforms like I, iOS or Android. It support different common languages like JavaScript, Python, Java, C, C++, and as I have checked right during the talk of Dennis, there is also the Rust support in the preview right now, so you can expect that it will be available sometime in the future. It have core capabilities to build your own logic inside of your devices, and of course it's going with end-to-end security utilizing TLS 1.2 or later. And after that, we have all our data are streamed, and or our devices are connected to cloud and gather the data. We need to do something with the data. And for these cases, service like IoT Wise coming to help. IoT Sitewise is managed service that enable industrial enterprises to collect, store, organize, and visualize thousands of sensors data stream across multiple industrial facilities. It can be installed on the edge, it can be used in the cloud. You can uh, ingest data ingest data from different sources using the MQTT, using the OPC UA, and different protocols. It can be ingested The data can be ingested directly from the SDK, and the data can be not only ingested but as well enriched during the ingestion and storage. You can create the models. You can create the models based on the data that are coming to your storage, and as well you can do hierarchical models to organize and manage your data in the way you would like to. Um, Using the Sitewise, you can also store the data in time series manner to do the real-time analytics on it using the warm storage, which will provide you the high performance and very nice capabilities of things that you used to have in different time series databases to aggregate data, to do the analysis on the data, to have low latency on analyzing data in real time or close to real time. Or you can use data in the cold storage for optimizing your cost and do analytics on the big variety of the or big range of the data to see the big picture of your of your devices and how they worked and what they have capable of. Another very important stuff is doing any kind of the transformation with your data or doing computation of on your data right in the store or before the just ingestion of your data, plus putting additional hooks, alarms, or events on your data so you would have such standard metrics that allowing you to understand when your sensors or when your facilities are requiring the repairment, what is the cycle of the failure, and so on and so on. And last but not, I mean, not last, but there is a lot of capabilities, but last which I would like to talk about is data visualization. As I said at the beginning, data visualization can be done on the on the cloud in the special website, which will be deployed for you again in the serverless manner, or it can be created as the dashboard right on the plant floor, where all the operation happening. It will be used through the secure method of the authorization and can work even when there is no connection to the internet. So bringing your analytical capabilities right to the floor, closer to the um, places where your sensors are installed and operates. And last but not least is device software, very important topic, which are interesting, which are like used by our customers. We have variety of capabilities for running the device, running our software on the devices. If it is very small devices like small controllers, you can use the free RTOS system, which will do the minimum work, like just sending data about current state of your sensors, like vibrations or whatever, do the underlying implementation of the security and update of this system through the IoT core or um, different another capability like green grass. Or if you have the gateway which is installed uh, on your facility or somewhere in the location when there is no internet, but you still need to process, analyze, and, for example, aggregate or run ML workloads like um, whatever training or using the like inferentia of your models. For this, we have the IoT Greengrass, the solution which can be deployed on whatever device that can basically run Linux. So, but before that, we were talking to our clients and we realized that usually um, there are multiple ways how you can work with your solution, how you can deliver or mm, create your solution. And there is like option one, like buy hardware, build your application and build supporting layers of your stack from the scratch. You can also buy hardware, build your application, and buy some IoT supporting layers and then integrate all this stuff and test these pieces and make sure that it's all working together. And the last one is, or not the last one, but another one is to buy the hardware, build your application, and use Greengrass to take care of your IoT supporting layer. With like all of these are all of these three approaches have their benefits and problems in the end, but in like what we found from our statistics and our customers, that using IoT Greengrass bring them such capabilities as low time to market, less maintenance, and easier operations in the end. IoT Greengrass can work. Basically, IoT Greengrass is an open source edge runtime and cloud service that helps you build, deploy, and manage your software. Customers can use Greengrass on the devices that are constantly connected to the internet, like, for example, some appliances like TV or media servers or whatever, which are like working in the facilities which have dedicated internet connection for this device and constantly running. Or Greengrass can be deployed to the hub, to your gateway, and then manage and collect the data from variety of smaller IoT devices on your factory facility, mm, whatever, you name it. And then time to time, when the internet is connected, it can offload the data into the cloud, or it can do the computation. It can do inference on the on device itself. It pretty useful. Usual use case is to do the aggregation of all the data that are coming from the smaller device into the hub, do the shrinking, do the remapping of the data, and then decreasing the amount of data that need to be streamed into the cloud for like more efficient processing. And taking talking about these two variants of the managing the devices and deploying the devices, we can find these capabilities of Greengrass. Is first managing the software on our IoT devices, updating the runtimes, updating the packages, integrating it with the core cloud services like mm, Lambda function or DynamoDB through the SDK that can be installed, or just stream the data into the IoT core. It can control device fleet, like gathering the data, sending the command turn on, turn off, and so on, or be used as the data broker. Or, as I said, you can use it for powering your sorry, ML workloads on the edge. And when we are talking about the benefits which can be calculated from the using of the or counted, which can be used um, from using of the ready solution like IoT Greengrass, is saving your time to market. So based on our observation, it can save you from 6 to 9 months comparing to building your own solution with similar capabilities, or save you uh, like up to 1.5 million for the development cost. It's really depends on the country where you're building it, how you're using it, and so on. But you can imagine basically the numbers. Or main lower your maintenance costs or operation costs. In the nutshell, um, what is like green grass? Uh, it's basically the open source software that can be installed on Linux, Windows, and other systems, which are consist of core component, what we call nucleus, and then you can install additional components like CLI, local Lambda functions, Docker containers, or bring your own runtimes there to run your local workloads, run your local edge computations, do the different type of the streaming or inferentia and so on. So it can work without or with the internet, and you can bring your models. You can update it remotely from the cloud, single device or millions of IoT greengrass devices. And then you, in the end, you're paying just, I'm sorry, in the end, you're paying just for the IoT greengrass devices that are connected, was active in the at least once in the month to the cloud. So if your devices which have installed IoT greengrass and running somewhere in the sea for 6 months is without any internet connection, and then just once per month, once per 6 months is offloading the data into our data center, you don't pay any extra cost for it, basically, just for 1 month. And yeah, as I said, there are edge capabilities like local messaging, data storing and synchronizing the state, inference of the ML workloads, streaming the data, storing the secret for your local devices, or update, stop device like small IoT devices, restart devices, send the logs, do the automatic recovery, and so, or use the such things like over the air updates, use local tools, uh, help with the remote app management, like for using your mobile phones, or remote manage the whole fleet of your devices on the factory. I'm almost out of the time. I think that's all what I wanted to tell you about the fleet of our services. This is just a small part which can be covered through this period of time. But if you will have any kind of the additional questions or you need our support, feel free to write me. I will do my best to uh, to to support you in your journey with AWS IoT services. Thank you for your attention.
Thank you, Alexei. It was really insightful, and it was something like a guide into the IoT technologies hosted by AWS with so many opportunities. It was really nice. Thank you so much. I guess we're done for today. Thank you, everyone, for investing your time to explore the IoT landscape with Yalantis and our star speakers. By the way, just a quick reminder at the end, if you're going to be in Amsterdam, attending those conferences named Tech Expo Europe and the Things Conference, let's meet there and continue our conversation around IoT and ask the questions you haven't had an opportunity to ask at this moment. But in case you still want to get more information from our speakers and from Yalantis in particular, feel free to email us at hello@yalantis.com. Feel free to visit our YouTube channel and our LinkedIn channels. Head over to both Denis's LinkedIn profiles. They're really happy to connect and answer your questions. And it was a pleasure to host this meeting. It was a pleasure to get so many insights into the IoT landscape. Hope you had a great time, and all of the recordings will be shared with you by email, so no worries. If you missed something, you can rewatch it and take a look at it again. Thank you for being with us today, and take care and goodbye.